welcome to Jess from Brain Trust.
Thank you. Oh. Awesome. All right. Hi, everyone. So I'm Jess from Brain Trust. I'm a bit shorter, so I'm just going to stand over here. Brain Trust is a platform that lets you do observability and evals for your AI tooling. So pretty much in this talk, I'm going to talk about what evals are, why they're important, and then I'll talk through a real-life, pretty complex eval that we ran a couple weeks ago. Okay, so I have been in legitimate calls where teams have told me that they've shipped AI features, either one, because the engineering team told them that it was ready, or a PM tried a couple of prompts and they said it looked good. That's very problematic because you're essentially making ship decisions based off of vibes, which is not good. Ideally, you would like to be able to quantify when you're shipping by saying things like, we ran 200 different test cases and 94% of them passed, and so therefore we're shipping it. Or to be able to say nuanced things like, we shipped this change and it improved the tone, but decreased accuracy by 5%. This is why evals are important. Actually, can I get a raise of hands of how many people have heard just the term evals? Or, okay, good. Okay, glad we're on the same page. Okay, so evals are important for a couple of reasons. They can answer questions. So which LLM is the best choice for our needs, especially when new models drop? This is always a big question in our minds. How does the AI perform across diverse real-world scenarios? So for example, it could perform really well on Python code bases, but not TypeScript code bases. It could do really well with English inputs, but not Japanese. Cost efficiency, can we achieve high performance without excessive costs? Does the AI reliably reflect our company's voice and standards? Are we learning from users and improving iteratively? And how do we know when something breaks or gets worse? Actually, this is a really interesting real-world scenario that happened. So in April of 2025, so about a year ago, OpenAI actually had to revert an entire model update because the changes that they made to make it more helpful actually made it too agreeable and therefore not very useful. And so this is an example of when it's very easy to overtrain models, and so you want to be able to catch these nuances early on. Okay, so there are 4 major parts to kind of creating an eval. The first is you have to create a data set. So a data set is going to be a collection of test cases that you are going to pass into your system. These are usually going to be your golden use cases, your edge cases, and then failure modes. Then you need to write a task. So a task is going to essentially tell your system how you want it to behave when it takes in an input and gives you an output. So this is usually in the form of a prompt and then also picking a specific model to do this task with. Then you want to write a scoring system. So for your scoring system, essentially, it is what tells you whether the AI's output is good or bad. There's a couple, if you've heard of them before, there's deterministic scoring, there's LM as a judge, and there's human in review. But essentially, you who are writing the score is defining the criteria of what comprises what good and bad is. And then the last thing is you want to experiment. This is the most fun part, but essentially one run of this specific configuration of your data set, your task, and your score is equal to one experiment run. So as you are testing out different hypotheses and trying to tweak things in your system, these will all turn into different experiment runs. So then once you have a bunch of experiments, you can actually start to compare them. So you can essentially see if there are any regressions or improvements across your experiment runs. And you can also click into individual rows to see which test cases have changed. Brain Trust also has a feature called Loop, which allows you to query your experiments using natural language. So essentially, I can ask it, highlight problems in my experiments or highlight specific patterns that you're seeing in my experiments. Or if you ran a bunch of different experiments, you can ask it which experiment performed the best. I was honestly really skeptical of Loop when I joined the company, but I use it a lot now, mostly because traces, like long traces of like an LLM does a bunch of turns and it hallucinates or it drifts, is really, really hard to manually read through. And so I find that Loop is just better, it's faster than what I can do, and it's better at detecting these patterns than I can. Yeah. And then the last thing is you can log, so you can just wrap your code using the BrainTrust SDK, and you can start to get live production logs. So the way that we chain this all together is essentially you have some sort of application. So for example, let's say it's a documentation page with a chat bot on the side where people can ask questions about documentation. So what happens is you have users or customers that use the chat bot or the chat panel, and so you start to get live production logs that have the user question as well as what the LLM responded with, and then whatever metadata that you want to pass into those logs as well. Then you can take those logs and sample 10 to 20% of them, depending on how much traffic you're getting in production, and turn that into a data set. Using that data set, then you can start to write evals. So you can start to tweak the data set or tweak your score or tweak your prompt. And you might try to write a prompt that is more concise, or you want the AI to answer more enthusiastically, or things like that. Whatever you and your team think is correct for a response. And then based off of how the evals do and what you learn from them, you will then bring that back into the app and ship code changes and tweak the app based off of what you learn from the evals. So that's usually how it works in a loop. If you are the type of person who's taking pictures on your phone, this is the best slide in the deck. So it's the one slide I did not make. But my coworker made this slide, and it's just so good that our entire team has been using it over and over again. So evals are a team sport. I really like this. Evals, on the right, you can see they comprise of a lot of different steps. If you've ever done an eval before, you'll understand that it's a living, breathing machine, and it requires a lot of components. So you have like the AI engineer that is bringing data to the platform, as well as obviously making the bug changes and feature changes as well. Then you have the product manager who, if you work at Kilo Codes, might just be the same as engineer because they don't believe in product managers. But I mean, sorry, that came out aggressive. But like they could be the same thing, which is totally fine. But they are the people who develop hypotheses or also tell you what the success criteria is. Then you have subject matter experts who help label the data or tweak the prompt. This is especially useful, I've seen in like medicine fields or law fields or insurance fields where there are very niche subsets of knowledge and you need subject matter experts to help you like label data. And then you have data analysts that help you define the scores and obviously analyze data. So evals are a team sport. Okay, so now that we've kind of gone through a lot of the concepts of evals, I thought it would be interesting to tie it to a real-life scenario, a real-life eval. So I wanted to talk about an eval that I ran to measure which one is better, agentic search or vector search. This was actually an idea from our CEO, Ankur. He often pings me with things I should eval. I do ignore him about 99% of the time, but this one was interesting. So he is on Twitter a lot, and he sent our Slack channel this article from Cursor talking about how they use semantic search, I call it agentic search, to significantly improve their coding agent experience or performance. after a quick search online, I did see there was a lot of discourse about whether agentic search or vector search was better, and I just thought it would be an interesting thing to independently eval. So we did that. Okay, so because we were comparing agentic search and vector search, I just thought it'd be good to get us all on the same page about what vector search is. So vector search is essentially the process of converting data, like text or code, into numerical representations called embeddings. These embeddings capture semantic meaning, so similar items will live closer together in a very high-dimensional space. So if you look at the chart on the right, you'll see that words like Wild West and Broncos are close together, basketball and soccer are close together, and antelope and wild beast are close together. Obviously, this is a 2D representation, but you can kind of imagine this in an n space dimension. And then what happens is that these embeddings get chunked up and stored into a vector database like Pinecone. So for example, if I were to ask where does the database logic in my code base live, essentially my code base would be vectorized and embedded and stored into my vector DB. And then the vector DB would find the closest embeddings that match my query, so words like database or logic. Okay, so then what is agentic search, also known as semantic search? So agentic search is what tools like Claude Code uses, and essentially what happens is the LLM has access to CLI command tools like grep or find, ls, cat, things like that. And it basically reads the code very similar to how a human would. So it would search for a function name, open the file, read the file, sees that the file calls another piece of logic or another function, and then follow that reference and repeat until it finds whatever it needs to. So it's more like how a real human would act. So that's the difference between agentic and vector search. Okay, so now that we understand the differences, let's build an eval to see which one worked better or works better. Okay, so for this experiment design, I created 2 different data sets. So the first one was using Microsoft's TypeScript Go repo. Essentially what we did is we pulled merged PRs from that code base, anything with the word fix in the title. And then from there, we checked out the parent commit so that the code base was in a known buggy state, essentially before the fix. And then we used Claude to synthesize a bug description for that PR diff. So essentially, we're trying to get like a format, like a linear task or like bug ticket. And that way, we can pass it into the agent and tell it to find the bug and fix it. And then we used the Go test suite as kind of our, like, if it passes the Go test suite, then it passes the eval. So hopefully that makes sense. And then the second data set is essentially using the same thing, but we basically pulled a couple rows from the industry standard SweBench verified. Have people heard about, do people know what SweBench verified is? Okay, a couple less people who knew what evals were. It's, if you read like any sort of, it's what like Anthropic and OpenAI use to like benchmark their models. So it's like more of an industry standard. So we pulled 25 rows from that, specifically from the Django related data rows, but the idea is the same. And then the reason why I used 2 different data sets is mostly because I just wanted to have some variety, and I wanted to test agentic search and vector search on 2 different languages and 2 different code bases. So Django is much more of a massive legacy code base, and TypeScript Go is newer and more modular, so I just wanted to see if there was any difference in how they performed across 2 very different types of code bases. Okay, so the next thing we had to do is implement vector search and agentic search. So implementing agentic search was really easy because Claude Code uses agentic search by default. So all we did was just set Claude Code on all of these tasks. For the vector search variant, that was a little bit more difficult. So essentially what we did is we implemented a basic vector search and had the agent call that through a script. But the problem was we still wanted to use Claude Code to keep the eval experiment as consistent as possible. But the key constraint is we actually had to prevent Claude Code from falling back to agentic search, which it really wanted to do. So this took like a couple of days. I had to really block it from using agentic search and try to call that vector search script every time. To do this, we basically did two things. So I used Claude Code's disallow tools flag to block any agentic search, so block calling grep or find or things like that. And the second thing I did is I very explicitly said in the prompt that anytime it wanted to use search, it should use vector search. So I believe this is a screenshot of the prompt I used. But yeah, without these two things, it would continue calling agentic search, which would have screwed up the whole experiment. So we really had to make sure that it was only using vector search. Okay, one other thing that was difficult when we were doing this eval is that Claude Code runs as a subprocess, which means that the traces were orphaned and they weren't actually being connected to the parent trace ID. So the fix that we did here was passing in the parent span IDs as environment variables so that the subprocess could actually attach itself to the right trace tree. If you don't know what that means, don't worry, I brought pictures. So here is what the trace looks like before we did that fix. So you can see it says run Claude agent, but you don't actually get any visibility into what the Claude agent is doing, like what it's actually trying to do. And here's what it looks like after we implemented the fix. So you can see that now every single LLM call and command line execution is logged in the trace here. So you can see it's calling Claude Sonnet, and it's running things like find and read and things like that. And you can also see like in the LLM call like what is actually inputting and outputting to the LLM. So yeah, this was really critical for us to implement because it allowed us to actually debug why certain things were failing or passing. And then in terms of the scoring, we just implemented kind of just one scorer, which is essentially did the fix pass all the repo's existing tests. So if they passed, then the eval run got 100%, and if they failed, it got a 0%. There is one interesting nuance here for the SWE-bench dataset. So SWE-bench actually gave us a test suite called fail to pass, which is essentially a list of tests that were failing before the fix but should be passing after the fix. But the interesting thing is if the fix passes everything in fail to pass, but then fails another test that's not in that test suite, it still passes the eval because technically it did fix that specific issue. So that's just an interesting nuance I wanted to note there. And then we also tracked metrics like duration, total tokens, and cost. Okay, so here are the results. So for the SWE-bench dataset, which was, again, the 25 Django-related code bugs, the vector search got a 60% accuracy, so it passed 60%, and then Agentic got a 68% accuracy. And then for the TypeScript Go code bugs, the vector search and agentic search actually both scored 70%. But as you can see here, vector search spent a lot more tokens and money. When you look at these results, the one thing I'll note is I would take this with a grain of salt. I highly doubt that vector search cost me over $4 per run, because if you do the math, that's $40, and it didn't cost me $40. So I think the exact cost is probably off, but what I would look at is the comparison between vector search and agentic search, essentially seeing that agentic search is X multiplier cheaper. So another thing I'll call out is the reason why I don't have the metrics for SWE-bench is because I was running this eval last night, and it takes a really long time to complete, and so I just didn't have time to get the numbers for Sweetbench. But yeah, yeah, doing this last minute. Okay, so there are 3 main takeaways that I got when I looked through the results and also the Claude Code traces. The first interesting thing was that vector search returns a lot of chunks of code. So in these chunks of code, there might not be like the relevant imports or relevant type definitions or the relevant code, calling code above it. And so essentially the agent doesn't get enough signal for what else to look for. So for example, in the Sweetbench dataset, one of the runs, the agent made 26 different vector search calls. Essentially, it was just trying to like guess and check so many times, and it just couldn't find the right place in the code base where the bug was happening. And the contrast is, in agentic search, the agent can essentially look for the function name, read the entire file top to bottom, see the import chain, and then follow it and solve the task a lot more quickly that way. So the way that I like to kind of think about it or conceptualize it is that vector search gave the agent a lot of proximity to relevant code, but didn't give the connective tissue between the code for it to actually implement a fix. The second thing is agentic search was able to do a lot of chain of thought exploration. So it's kind of what I mentioned before, where it's actually able to look at the function and see what calls it and actually be able to travel to different files to follow the logic, whereas vector search can't really do that, at least in the traces that I saw. And the third thing is the more searches, the more expensive. So the reason why vector search took so many more tokens and took so much more money is because it was making so many more calls, because it just couldn't find exactly where in the code the bug was happening. So that's why it was so much more expensive. Now, the last thing I'll say is I don't consider this eval close to being done at all. Like, I would not publish a blog post about this yet, mostly because just from a gut sense, this eval basically is saying that agentic search is 100% better than vector search, which I don't think that's the case. I think there are places where vector search is better. And so something I would do is, one, I would run multiple trials per task. LLMs are very non-deterministic, and so I would not be surprised if I ran this eval multiple times with all the exact same criteria, that it might have a difference of 10 to 15%. So that's one thing, that I would run multiple trials and kind of average the scores across them. The second thing is, honestly, I think I would improve the vector search implementation. It was a very basic vector search implementation, so maybe that's why it's not performing that well. I'm not an expert on vector search, but I do think there's things like chunk overlapping or splitting the text or retrieval models that can be implemented to improve vector search. So it might just be that my vector search implementation was just bad. And then the third one, which is not really a blocker, but it would be interesting, is to try a hybrid approach. I do think a lot of companies now are doing a hybrid between vector search and agentic search. And then the fourth is to expand the data set. So obviously, a data set of 10 rows, if it fails one of them, that's a swing of 10% in the score. So just expanding data set, adding more rows, and also adding potentially more languages or more code bases. And that's it. That's kind of evals, and also example of how to use an eval in real life. Yeah, I think I only have 1 minute for questions, but we can do like 1 or 2 if that's helpful. Yeah, does anyone have any questions?
Thanks. Hi, I wonder if you did anything to try and isolate or characterize the token usage from restricting Claude from going into agentic mode?
Yeah. That would be something I'd add to the improvements. It was something I thought of. The short answer is no, I didn't, but I did think of it.
That's
So it was definitely something I thought could be inflating the token count. And so as I'm trying to iterate on this eval, I would definitely probably look through the traces, like the Claude Code traces, and see if it's inflating the token count every time it's trying to essentially do an agentic call but can't do it, and then has to switch over to vector. So yes, yeah.
And one more question, if I could. Have you run against human respondents?
Like having a human
as
review
a control group for a similar set of questions or a subset of the questions that you're asking the AIs?
Wait, sorry, say that again?
As a control group for questions that you're asking AIs, have you considered asking humans for responses to those and measuring differences?
Yeah, that's a good question. So the SWE-bench dataset actually comes with a golden answer. So SWE-bench, because it's an industry standard, already has like the answer key essentially that was like human coded. So we could technically compare it against that human like golden the answer set essentially for SWE-bench. For the TypeScript Go ones, I guess technically because these are merged PRs, we can also just compare it against the actual fix from the PR. So I guess we could actually compare it against the actual code and probably use some sort of like LLM as a judge to see how close the code is. So I haven't done that, but I think that's a really good suggestion. Yeah.
First of all, thank you for the presentation. Yeah. I'm curious about this. I work closer to the users. And one of the things that we are seeing as we are building a conversational AI product on top of data is that we are starting to deal with a lot more people who have smaller attention spans. And what that means in translation of the product is they will start a question, for example, thinking about where can I get a matcha? From there, they will go to where can I buy a Lululemon? From there, they will go to the latest price of Tesla. From there, they'll go to something else about Elon Musk's latest conspiracy, whatever. Now, what I'm curious about is it is becoming increasingly harder for me to think about evals in that perspective because the idea of a golden data set suddenly doesn't make sense to me. It's impossible for me to emulate the thought of this person. I've thought about maybe getting a synthetic agent to like think about this. But for a case like this, where there's not going to be a straight chain of thought, there's not going to be a consistent golden data set. How do you think about evals? And are there something that you may have published that we should probably be thinking about or reading about?
Yeah, definitely. So I think if you are seeing it in your application or if you're seeing it in whatever product that you're building, that's enough because essentially you should be able to log that and turn that and add that to your data set. So if you're seeing people who have short attention spans or are jumping through different questions or different parts of your app, that should be logged somewhere, and you should be able to turn that, add that to your data set. So that would be my answer. Then from there, sure, you can use AI to add more synthetic rows to your data set based off of that, but I think that's the biggest thing, is just to turn your actual user journey into just something in your data set. Yeah. Okay.
Awesome.
Yeah.
Thank you, Jess.